Hi all, myself Sneha Giridharan, Assistant Professor, Department of Computer Science and Engineering, VVIT, and my topic is removing atmospheric turbulence via deep adversarial learning. Image restoration through atmospheric turbulence is one of the well-researched topic. Its applications involves video surveillance, defense system, and the drone imaging system. These systems capture images of objects at a distance of several kilometers. So the slight changes that happens in the atmospheric conditions due to the atmospheric turbulence results in the changes happening in the object image. Therefore, there is a need to develop some image restoration method. Deep atmospheric turbulence is like a shearing effect and gets unevenly distributed into the different parts of the image. Advancement in the deep learning helps in approximate mapping from turbulent image to its original image. So it is very difficult to minimize the atmospheric turbulence of an image with the help of a single stage deep network. Therefore, there is a need for the network having the two stages. Step involves removing the geometrical distortion with the help of a RapNet, and the second is with the help of a ColorNet that removes the image blur in order to improve the overall perceptual quality. A channel attention and a subpixel mechanism is also added to utilize the information between the channels and to remove the atmospheric turbulence. The model used here is the DTD GAN. Artificial injection of atmospheric turbulence systematically into the images are done here with the help of some 2D operations. A dataset is curated from the YouTube having natural atmospheric turbulence and to show the generalizability. The restored images are used for the depth estimation, classification as well as the detection. The related works. The restoring images in the atmospheric turbulence can be classified into two. First one is the adaptive optics and the second is with the help of lucky imaging. Adaptive optics requires expensive and massive instruments for removing the atmospheric turbulence, and they are mainly used in various kinds of astronomical applications. Next is with the help of lucky imaging. They take short exposed distorted images, select some lucky regions, and these regions are fused in order to get the final image. In image enhancement, these methods use a multi-frame image reconstruction approach to correct the geometrical distortion and the image blur. In video enhancement, fusing a stream of randomly distorted images is done. Large number of machine learning techniques are used, and all these techniques have several limitations. So they fail to restore image using a single turbulent images. Now, image to image transformation via deep learning. The recent success in the deep neural network improved the performance of the image processing technologies. So these networks can be used to generate the natural images using a deep generative networks. The GAN is one of the most popular network that is used for the photorealistic output, and the most important GAN based denoising method is used in tomography and microscopy. Attention mechanism in deep learning. It is selectively concentrating on a particular piece of information and ignore the rest of the parts. They are used in computer vision as well as natural language processing, and they can also be used in the denoising, deblurring and super resolution purposes. Now the methods. Introducing an array of residual blocks and dense residual blocks along with some channel attention module, and this is done to improve the overall restoration. A subpixel mechanism that removes final geometrical distortion and to produce a high quality restored images is done. Residual blocks. The residual networks are very well known in the various computer vision tasks. So these are the residual blocks, and these are the dense residual blocks. The instant normalization layer is replaced by a group of normalization that works better in the broader image with a good training stability and accuracy. The residual blocks is replaced by the dense residual block, and they can access all the subsequent layers and pass the information. The network architecture involves the RapNet and the ColorNet. The RapNet removes the geometrical distortion by creating a wrap field around the input image. The experimentation involves the dataset, simulated atmospheric turbulent dataset. The virtual camera parameters used for creating these image datasets are the focal distance, lens diameter, and the pixel size. Using these parameters, turbulent images from the ImageNet dataset are rendered, and the dataset consists of 4 lakh turbulent images and the original image from pairs from 1000 classes of ImageNet. And these are the examples of the synthesized samples. Now the real atmospheric turbulent dataset. A test dataset is created having the natural atmospheric turbulence, and the images are curated from the YouTube videos, and these video frames resulted in thousands of images. The manually selected frames with the distortions are resized into 256 into 256, and there are 13 and 217 images with a significant distortion and moderate distortion. These are the examples of the real atmospheric dataset. Training and implementation details. The proposed restoration network is trained on 400,000 pairs of turbulent and the original images, and each image is randomly flipped horizontally and resized for the data augmentation followed by the cropping. And each training batch is normalized with a mean of 0.5 and a standard deviation of the 0.5. Now the image quality metrics. The image quality is an important measure to evaluate the perceptual and structural information present in an image. To measure the quality peak, signal to the noise ratio, structural similarity, and the mean square error is calculated. Restoration details. The DTD GAN performs better than DT GAN as it removes the finer geometrical distortion. Here the figure shows the various comparison of the restoration methods. So the DTD GAN pre shows lower performance than the DTD GAN, which can be overcome by adding the higher weights to the noise or critical features. In DTD GAN, all the features are passed through 1:1 convolution layer that squashes out relevant features and better performance. Comparing with the other restoration models suffering from geometrical distortion, its performance is very much higher. The model minimizes the image artifacts and the finer atmospheric turbulence prominent in other baseline methods. The DTD GAN Plus removes the self-ensemble strategy, and introduces a blurriness in the final output, and the method gives a high quantitative results on the various kinds of image matrices. So, while considering the analysis of the various distance and the structural construction constant restoration, the two parameters that is used for controlling the atmospheric turbulence are object distance from the camera and the refractive fluctuation of an environment, which is characterized by a structure constant Cn square. The proposed model performance are analyzed with the various object distance and the Cn square, and the model can restore images at various strength of Cn square. Now the conclusion. A deep adversarial network to minimize the atmospheric turbulence is proposed here. Unlike the other models, this model neither utilizes any prior knowledge about the turbulence field. It doesn't combine the multiple images to generate the restored image. A large dataset is used for the overall training purpose of the model. The proposed model performs a state-of-art performance, and this research opens a new direction in the relatively new and narrow area of restoring atmospheric turbulence.